Well, good day, and welcome to another session of the World Oil Podcast. My name is Kurt Abraham. I'm Editor-in-Chief of World Oil. And today we are at the Baker Hughes test rig near Angleton, Texas, and we're going to be talking about the AccessESP technology. With us today are three Baker Hughes SMEs. To my right, we have John Raggio, Keith Russell, and Morteza Fogarty. And we're going to talk about various angles of the ESP, the AccessESP technology. So let's just dive into this right away. And John, maybe you can tell us a little bit about this site that we're actually doing the podcast from.
Yeah, so this is our Rigless ESP test facility. This started out as a gas well in a former life and was converted into a test well, basically, for us to test Rigless ESP technology. So the idea behind this facility is anytime we're trying to push the limits of the technology, releasing new technology, maybe trying new applications, or just trying to give ourselves and our customers a good feeling that we're going to be successful on the first try in a new country, we'll come out here and do tests with the AccessESP system.
So maybe you can explain a little more the crew that we see out here out at the test rig. What are they working on today?
Okay, so today we're testing the latest and greatest version of our Access A450 system. So this is a 1,000 horsepower system that's capable of up to 20,000 barrels of production per day. So right now what we're doing, we've installed the permanent completion, which is the receptacle end of the AccessESP system, and we are in the process of installing the retrievable assembly, which is the wireline ESP portion of it.
Excellent. So, Keith, maybe you can tell us a little bit about what are the things that you're looking for to make sure it's ready.
Yeah, well, great. Like John said, we've installed the permanent completion, which is basically the tubing and the cable and the downhole wet connect where we will in the future plug the motor into. And then we've permanently rigged it up to the flow loop here where we're going to test it at its full capability. We've also run the motor in a wet system and plugged it into the cable. And now we've run the pumps, and right now they're in the process of running the final tubing pack-off, we call it, that allows the fluid to flow up the pipe. So once all that's installed, and some of that is just like John said, for the operating company to practice, we'd much rather get our work in here and develop procedures here than offshore in a $500,000 a day offshore jackup rig. So once it's installed, then we'll fire up the motor with a real VSD, the same as we'll run it offshore, and we'll flow it under flowing conditions for, I believe in this case, it's 5 days or 60 hours of continuous test at its maximum rate and pressure and as high a temperature as we can get in the flow loop here.
So if you add up all the different phases of this project, how long does this test take? How many days, you think?
Well, the permanent completion we're running very shallow here, so it's much shorter than offshore, which also saves them money. But the permanent completion will take about 2 days to run and get the cable through the wellhead and terminated properly. The retrievable system has been run today, so in 1 day. And that's one of the advantages of this system is it runs very inexpensively and quickly to pull and rerun just the pump. So it will be here about a week of setup and installing and a week of testing.
So, Morteza, a question for you. Maybe you can explain to us why this technology is such a game changer for the industry.
Very good question, Kurt. And very simple answer for that is because we are pushing the boundary with this test. What that means, specifically for offshore wells, particularly deep water wells, which we are at the higher end of production rate, 20,000 and more, with high oil cut, it is critical to keep that well operational all the time. And by any reason, if ESP, electrical submersible pump, fail downhole, that will impact the global energy supply. So it is important to bring the well back online and operational again. So with this system, we can bypass all the long lead time that unfortunately that's a reality for offshore rigs that takes months to move the rig to the location and cost a lot. This is the right technology to quick change the downhole equipment and bring the well back to the operation.
And that's really the name of the game at the end of the day, is to do things more efficiently at less cost, right?
Cost, exactly.
Yeah.
Exactly.
Less rig time and more run time, we say.
There you go. So, John, why is this AccessESP technology better than what we would call traditional coiled tubing systems, and how it would compare to some of the similar things that are on the market?
Yeah, well, a couple of reasons. When you compare it directly with coil tubing or cable deployed systems, we're able to get a much higher rate, more comparable to a similarly sized conventional ESP system, I would say. And then if you look at maybe more like for like with a receptacle and a retrievable assembly technology, ours features a full bore, which is very valuable to operators to just being able to conduct the normal course of business for a well. So if we need to do any kind of through tubing intervention, squeezes, wellbore cleanouts, we can actually pull the retrievable assembly out, go through tubing, do all that work, come out of the hole, and then plug right back in, all without using a workover rig.
Now, that sounds so much more efficient and flexible for the operators.
Indeed.
Yeah. So, Keith, you talked about PMMs being standard. Are you beginning to see some savings with that?
Yeah, one of the savings of this system is a permanent magnet motor, and they typically run much more efficiently than the conventional induction motor. And that can be as much, depending on how underloaded the motor is, it can be anywhere from 8 to probably typical in what some of our operators have published, about a 25% savings in electrical cost. But PMM motors are becoming fairly common, so that's not the significant savings of this system. It tends to be, as Morteza said, when an ESP well goes down, which they do after so many hours of operation, you can get to the well very quickly, and you can pull it and rerun it very cheaply. So it's the primary savings are the time to get on location and not lose production during that period of time, and the cost of the workover itself. So we have a little system we call the economic value analysis that we do for clients, and in a typical offshore Mexico or U.S. situation, where a rig can cost as much as $15 million to do a workover, and it often takes anywhere from 90 days to 180 days to get that rig. So the well's down for that period of time. Also, the slickline unit may cost $250,000 at the very most. So the difference between $15 million and $250,000 is very significant. So what we do in the economic value calculator is we do a net present value over a 10-year period, assuming some run life for an ESP. And in the typical offshore Gulf of Mexico case, the net savings between the rig cost and the lost production, the last case we worked on was $67 million in 10 years for one well. So tremendous savings above and beyond the permanent magnet motor.
No, sounds excellent. So looking offshore, you mentioned that a little bit. Does AccessESP work in subsea applications just as well?
That's really the next frontier. We're ready to go. We have all the pieces in place to do that. The completion below the tree is exactly what you're seeing run out here today, and the completion inside the tubing is the same as you're seeing run today. The only real difference is the tree itself. All of the riserless intervention technologies are the same as would be run on wireline today. So really all the technologies exist. We're in the middle of a feed engine study, a front-end engineering design study, to really test the interface between the subsea tree and our cable. And that's really the last piece we need. And the next step is for a customer to commit and go run one.
So what you're saying is that we can look forward to more of this in the relatively near future.
Yep, we're ready to go.
Excellent. Morteza, what would you say is the next step forward in the overall evolution of the AccessESP system?
Well, as Keith just mentioned, with this test and the result of that, we can open a whole new market for AccessESP, specifically for the cases that we need more prolific system that on the deep water, higher production rate. We come back to our valued customer and said, hey, we have right system, we tested, and let's use our system for the cases that production rate and lowering and downtime is critical for the applications.
Understood. Gentlemen, is there anything that we haven't talked about that you want to mention quickly?
again, I would maybe reiterate that our clients really use this facility as a place to train their operators. We've had people fly their whole slickline crew in from West Africa to train, so that they spend less time on the rig when they actually go to pull and rerun equipment. It's a much cheaper place to learn and write your procedures than on an offshore high expensive rig.
Well, the fact that a company would bring personnel in all the way from Africa, that sounds to me like a ringing endorsement of the technology.
Yes.
Very good. Well, thank you all so much, and thank you all for listening, viewing this episode of the World Oil Podcast, and stay tuned for a next episode. Thank you.